Robert Stirling invented the Stirling engine in 1816 as a much safer and simpler alternative to the steam engine. In fact, steam engines routinely exploded in those days. Then, the internal combustion engine took over. But the Stirling engine could be the engine of the future. We fueled up our Stirling engine with denatured alcohol. We fired it up, and after a few minutes, it started up and ran well. We measured the speed in RPMs, revolutions per minute. We measured the heat of various components. We tested the voltage. And whether it would light up a small LED. As the fuel started running low, the heat and the speed decreased quickly. We then knew it worked, so we decided to take it apart and see what made it tick. Once the engine cooled, we disassembled all the components. We were careful to tag each part and assembly group and kept them organized. A simple animation shows how the engine works. The internal gas inside a sealed cylinder heats up, moves the pistons, a crankshaft flywheel assembly stores the kinetic energy produced, the gas cools down, and the process repeats. We then reassembled it. We actually used all the parts. Fueled it up, lit it, and it ran even better than before. We had replaced the O-rings with higher temperature tolerant rings and had fine-tuned the crankshaft flywheel alignment. We think it's time for the Stirling engine to make its comeback, and we're not the only ones. The Swedish Navy powers its submarines using Stirling engines. These run on a low-sulfur diesel and liquid oxygen mix that does not require any ambient air for combustion, so the subs can stay underwater for weeks at a time. Also, the Stirling engine is so quiet that the subs are practically undetectable. The perfect stealth weapon. Now, from the depths of the oceans to the outer reaches of space, NASA is developing a nuclear-powered Stirling engine that runs on uranium fuel rods. The engine could one day provide power to a human colony on Mars. And to think it all started with this.